Hi, everyone. All right, we're going to reverse this now. I'm going to give you the point, and then there's going to be some questions asked. And partly this is not new. We could figure out sine, secant, tangent, whether this was special values or not. But part A is definitely a special values question. So we're going to try and figure out where we are. So there's my attempt at a circle. Negative 1/2 root 3 over 2. So my x is negative, my y is positive, so I'm in quadrant 2, and that y is a little bigger than x, so I'm closer to the top of the circle. So that's my negative 1/2 root 3 over 2. Okay, and we're supposed to name some possible t values. So I would hope that the first one that we would get would be the 2 pi over 3. And again, there's a memorization component, right? But we know it's going to be pi over 6s, pi over 4s, pi over 3s, pi over 2s. So we're looking at this and saying, okay, those ones that are more towards the top or the bottom of the circle, those are our pi over 3s. So there's 1 pi over 3. This is a 2 pi over 3. And then halfway around is a 3 pi over 3. So 2 pi over 3 is a possibility. And when I say that, I'm imagining this is my arc length. So I started at 1, 0, and I headed around till I hit that. The next one I'm going to go for, and you have your choice on this, you don't have to do it this way, is a negative. So that arc length right there. And I would say you can look at this a couple of different ways. You can just start counting your pi over 3s, just like we did for the top. So there's 1, 2, 3. It looks like that's a negative 4 pi over 3 is one possibility. Another way you could think about this is all the way around is a 6 pi over 3. That's always kind of a nice reference point if you're having trouble. Halfway around is 3 pi over 3 because that's equal to pi. All the way around is 6 pi over 3 because that reduces down to 2 pi. So if I know that I'm going backwards, so it's negative, and I stop 2 pi over 3 before a full lap, that's basically 6 pi over 3 minus 2 pi over 3 is 4 pi over 3. So I don't know if that's confusing or if that's helpful, but that is another way to think about that. How far are you from a full lap around the circle? And then from there, the 6 pi over 3 continues to be useful. We can just continue full laps around in either direction. So from 2 pi over 3, if I go another full lap, that's another 6 pi over 3. So we're just adding 6 pi over 3 at that point. 2 pi over 3 plus 6 pi over 3 is an 8 pi over 3. That's 3 answers. That would be great right there. You could also continue going negative. So you could go negative 4 pi over 3 minus 6 pi over 3 would be a negative 10 pi over 3. So any of that would be excellent. And I did say 4. I was thinking 3 from earlier, but there are your 4 values. Okay, we're also asked in this to find the values of sine, secant, tangent at this point. So again, we've done this before, but just practicing it again in the context of special values. So for sine on the unit circle, and I'm just going to say t because we don't know which of those 4 values it is, or it could even be a different one. But sine of t, that's your y coordinate. And my y coordinate at that point is root 3 over 2. Secant is 1 over cosine. So 1 over your x coordinate. So 1 over negative 1/2. And dividing by a fraction is multiplying by the reciprocal. So I don't know why I just put an x there. We're going to multiply by negative 2, which should just give us negative 2. And then last but not least is tangent, t. And tangent is sine over cosine. So it's that y, root 3 over 2, divided by your x, which was negative 1/2. Okay, I'll actually show my work here. Multiply by the reciprocal, so negative 2 over 1. And those 2's cancel, and we get just a root 3 for tangent. So keep working on that memorization with how you find the trig functions. And now we've got to add to that those points in quadrant 1 and then get really good at moving across the x-axis or the y-axis to find other points.